Hello everyone. Today we will perform an experiment that will be based on Bernoulli's equation. In this experiment we will empty a tank full of water by poking different sizes of holes in the tank. First, here is what you need to know about the Bernoulli's equation. This equation is a fundamental principle in fluid mechanics that relates the pressure, velocity, and height of a fluid flowing in a closed system. The Bernoulli's equation is derived based on the following assumptions and conditions. The flow is along a streamline, which is a line that represents the path of a particle of fluid as it moves through the fluid. The equation assumes that there is no work done by or on the fluid, such as frictional. The equation is valid for incompressible fluids, which means that the density of the fluid does not change with pressure or velocity, and the flow of the fluid is steady. When we combine Bernoulli's equation and the integral preservation of mass equation, we get an expression that gives a connection between the water level and time. In front of you, you can see the 3 holes that were used in the experiment. The diameter of them are 1, 2.5, and 5 millimeters. We measured from 900 milliliters to 300 milliliters to reduce the error that we would have gotten from the changing geometry of the lower part of the bottle. Let's evaluate the results that we got. The graphs in blue represent the values in theory, while the graphs in red represent the values that we measured in the experiment. It is important to note that the real measurements in the bottom graph are shown as a thinner red graph with a diamond shape. These measurements had noises, and therefore we used the discrete Fourier transform to clean up the results and get the red graph. The first part of the experiment yielded excellent results. The second part was also accurate. On the other hand, the third part of the experiment didn't yield accurate results. Here are some reasons for the inaccuracies. Firstly, we approximated the bottle that we used to a cylinder. Secondly, we may have inaccurately measured the size of the holes and the diameter of the bottle. Moreover, we used tracker software to measure the results, but there may have been an inaccuracy caused by the angle at which the video was taken. In conclusion, the third part of the experiment didn't follow Bernoulli's equation. We can clearly see that in the graphs. It did not follow the equation because the ratio between the surface area of the water and the size of the hole was bigger than needed in order to be in a quasi-steady state, which is an important condition. Thank you for watching.